2, 1. Yes. Here we go. We are going outside, and in preparation of this, we discussed rate of fall Friday. And we discussed that we're looking at objects as they fall through the air. And you're going to just write down a short description of how they fall. And we talked about whether one falls faster, if you want to say one falls slower, or if they fall at the same rate. And remember, we talked about the same rate. I may drop them uneven, but the object would still fall at the same rate. I have to have that on.
You have to confiscate your phone.
The objects might fall at the same rate. It's just that I dropped them unevenly. Maybe I dropped one quicker than the other by a split second. But they could still fall at the same rate. Remember that? If one was falling faster than the other, remember we said that distance would increase as they're falling. You would see an increasing distance. Remember that? It's important that when we go outside, you watch how they are falling in relation to one another in the air and not which one hits the ground first. Remember, some of the objects are bigger and some are smaller, and the big object might hit first just because it is bigger and it would hit the ground first. We're watching as they fall through the air, okay? The second round, I'm going to go up 40 feet, which is a little bit spooky, and I'm going to drop some more objects. The objects that I drop from 40 feet, you will make mental notes on, and I'm going to remind you of this, so don't stress about it. You'll make mental notes on how they are falling, their rate. You don't have to jot anything down on the last objects that we do, okay? When we go outside, you'll see the big lift, and I have 3 stools out there, and it has the yellow caution tape going across the stools, and you'll just go on the opposite side from the lift behind the tape. Now, part of the planning, I have planned and planned, and I had it pretty well rehearsed. I did not think about the sun, and the way I set the lift up, I'm standing with the sun behind my back, which means the sun is in your eyes, okay? It's a little bit hard. So it's perfect because a lot of people, you can shield, makes a great shield for the sun. You can also, let's say, if something happens, I died happy. That's horrible. That is horrible. All right, here we go. Wait, no, we're moving. Softball and a bouncy ball, okay? What if Cheaper got
She trips and falls out. Oh, you don't have science.
Yeah, but then hey, I forgot I lost my marble this morning. So when we get to the marble, I'm going to have to substitute something else. Okay, are we ready? Here, let's do it like this. You ready?
Go for it.
3, 2, 1, drop. Remember, short descriptions. Then you're not watching for when it hits the ground, but how did it fall through the air? And remember, we talked about this is 7th grade science. It's not ultra precision. We're getting the general knowledge.
Well, it did look the same, except that I was doing this.
It looked like the softball station.
I got the same.
Bowling ball and the baseball, okay?
Yeah.
Alright, 3, 2, 1, drop.
Boom! Woo! Baseball.
Boy, the sun's really going to be bad for the last hours. Oh, well, maybe so. Alright, here we go. We ready? Everybody looking?
You're a professional.
Alright, 3, 2, 1, drop.
Whoa, that's the same.
Yes. Toy and the Hot Wheel car. Alright, here we go. 3, 2, 1, drop. The next one. Now it's the soccer ball and the tennis ball. Here we go. Everybody ready? Are we watching? All eyes up here. We're going. All right, here we go. 3, 2, 1, drop.
With the tennis ball fell.
Let's do it this way. We ready? 3, 2, 1, drop.
Pretty close to the same.
Yeah. Piece of paper, push ball. Then we're going to do just some random ones, okay? Ready? 3, 2, 1, drop.
Hey, I should wad up the paper. Paper fell faster. Hey, we share it.
Turn around, look. I know these seem repetitive. This is a real important concept, though. Here we go. 1, 2, 3, drop. Oh, yeah. Why not? You to know it's about the same size as the bowling ball, okay? Are we ready? All right. You ready? All right, here we go. 1, 2, 3, drop. Okay. Ball and a softball. We're just watching, okay? 3. Everybody looking? 2. Whoops, I need to hold it the other way. 3, 2, 1, go. Hey, this is really spooky now, so all eyes up here real quick so I'm not having to wait on y'all. 3, 2, 1. Okay? There's a chicken, there's balls, rocks. Hey, and then don't drop them when I'll have y'all continue to hold them for me. Gather under the sign, and we're going to yell out, thank you, hand. Loud, like a cheerleader voice. 1, 2, 3.
Thank you, Handyman Rental!
Woo! Some suggestions, or make your observations for me, and tell me what you noticed about it. Yes, Jaded. Whoops.
Well, on when they had the bowling ball and the baseball, I recorded
reported that the baseball, right, JD, fell faster than the bowling ball. I love that. How many of you have that the bowling ball fell faster? Raise your hand really high. About 1, 2, 3. Okay, how many of you have them the same rate? Real high so I can see. 1, 2, 3, 4, 5, 6, 7, 8. So we're tied on the rate there. Remember we talked about 7th grade science. We are trying to get generalities. There is a pattern that should happen for these, and we're going to keep discussing it. So we've got kind of split on that. Tell me, how many of you, for sake of time, how many of you have that the objects, maybe over half of them, fell at the same rate? So raise your hand really high if your objects fell at the same rate, at least half or more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Awesome, those are great results. With 14, and I think we have 23 in class, that's a little over half. We have about 10, we have someone absent, so 9 or 10 students that got different results. We are going to discuss this more, but the results that the things fell at the same rate is the generalization or the observation that I was hoping that you would observe. How when we dropped all the balls that were different sizes, could you give me a generalization for the balls? Yes. About the balls. When we're dropping all at the end, you didn't have to record them.
That they all just fall at the same rate.
Anyone else could account for it? What did you notice?
That they fell at the same rate because of gravity.
More air resistance something has, the slower it falls.
Okay, so could you give us an example?
Like the paper, how it was flat,
Yes.
spread out.
Good, it fell really slow, didn't it? Bree.
That sometimes if it weighs more, then it will fall fast at
Okay.
a different rate than
Way more, soccer ball, they fell at the exact same rate. I love having, and next year I'm just going to do the round objects because those had the same surface area and it makes a really good visual for you. So when we discuss it a lot of times, we're going to talk about, refer back to the balls that we did at the end. I want you to raise your hand. I should ask this before we've shared answers. Don't raise your hand if you don't feel that way. But when we were dropping all the balls of different sizes, how many of you felt they fell at the same rate? Let's take account of that. You thought they fell at the same rate. So we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Called force in motion. That gravity, we're going to find out, is a force, and gravity pulls on objects with a constant rate. And we'll talk about that more, but y'all made some excellent observations, okay? Give yourself a round of applause.